The Stem Cell Review is presented by Celgene Cellular Therapeutics.
Type 1 diabetes used to be called juvenile diabetes, hence JDRF. It's basically a disease where the immune system attacks the beta cell or the insulin-producing cell of the pancreas, destroys it, and consequently the person that's diagnosed with the disease has to go on into insulin for survival. Type 2 diabetes tends to be later stage. It's often triggered by obesity, and it involves insulin insensitivity. So the majority of patients don't need to take insulin, although it's rather interesting, over 30% of type 2 diabetics are on insulin therapy. So there is a distinction. The facts are, though, that type 2 is becoming more of a problem in young people. So there's a blurring of type 1 and type 2 in terms of age. So there are some complexities. So what Novacell and a number of other companies and academics around the world have been trying to do is to go from the embryonic stem cell to being able to differentiate those cells, to coax them, to create insulin-producing cells or beta cells. And the holy grail, of course, is to create those cells and then be able to administer those cells to patients. Diabetes is one of the few areas where a cell therapy has been used effectively. And what I mean by that is that cadaveric islets have been used, removed obviously from the pancreas, and administered into the livers of type 1 diabetic patients. It's transplant, so those patients have to go on immune suppression to avoid the rejection of the islets. And those patients can live for a number of years completely off insulin. So that's proof of principle that a cell therapy can work in type 1 diabetics to get that patient off insulin. I met a number of these patients. They feel great, but unfortunately that won't last indefinitely. You're putting in cells into patients that have an active immune system that are going to destroy those cells. So you need to do something in addition to just producing the cells. And that's where you get into two different approaches. The first approach is simply encapsulation. You coat the cells with a material which will protect the beta cells that you've produced from the immune system, from the T cells and other immune cell types and immune proteins. There is some work ongoing showing that a number of approaches have been shown to be effective, certainly in animals, and there's optimism that this approach will be used clinically at some point. The second approach, of course, is to use a kinder, gentler immune modulation approach. To date, most immunosuppressions are very hard on the body. They can cause many side effects, and so it's preferable to avoid the use of current immune suppressant therapies in diabetic patients. And in this case, we believe that antigen-selective approaches might well be the approach to go after. So you would take a cell, whether it's from an embryonic stem cell or potential iPS cell, combine that with an antigen selective approach where you can down-modulate the immune system, hence the cells will survive, and hopefully will give the patient, allow them to get off insulin altogether and have a kind of a normal lifestyle, and obviously with glucose levels within normal range. It's very difficult, therefore, to, I say, dial up a pancreas. If you need a cell therapy for this disease, you really need an unlimited source of cells. And the only way to date that you can access those cells is using a stem cell product to start with as your early material. And the best source of those cells to date are embryonic stem cells. Because I think most people are aware embryonic stem cells have many, many divisions capable of accomplishing the production of billions and billions of these cells. So you can create a cell bank, and that cell bank, in theory, can produce enough cells for the whole population that needs a cell therapy for the treatment of the disease. Well, of course, you're well aware that embryonic stem cells have had some ethical issues associated with them, some challenges, financial challenges to get support to do this research, for example, from the government. So there are many different types of stem cells have been looked at to see if they can convert themselves to an insulin-producing cell. So many adult stem cells have been looked at from adipose tissue, for example, from amniotic cells. Some people have claimed some success using different types of stem cells to create insulin-producing cells, but none of those have really proven to be terribly successful. There's a very exciting new technology which is capable of taking adult stem cells and converting them into iPS cells, inducible pluripotent cells, which can then be converted into insulin-producing cells. Now, that cell population, the iPS cell, will be capable, possibly, of producing insulin cells in large numbers. But there are some people that believe you'll be able to create a personalized medicine. You take your keratinocyte, you convert it to an iPS line, and then you differentiate that iPS cell line into an insulin cell. So a lot of steps in that process, and unfortunately the iPS lines that we have today are genetically abnormal because they've been genes have been inserted, some of which are oncogenes, and therefore they're not ideal for the purpose of a cell therapy. But eventually, over time, that might well happen. So I think in theory, though, the human embryonic stem cell is a much more robust approach today. Now, obviously, we call that the allogenic cell approach, where you can create the cell bank to treat everybody. The iPS line is more of an autologous approach in theory, where you can take your own cell to convert it into a cell which you would then need. Clearly, recently the FDA has clamped down on the safety of type 2 products, and so it extends the clinical trials. With type 1 it might be a little different. There is some concern at the FDA that the cell therapies that are generated from human embryonic stem cells may have some adverse effects. For example, they may be tumorigenic. So the companies working in this field will have to prove to the FDA that these cell therapy products are very safe, because you are putting them into a patient population. It's not oncology. There is a therapy, it's insulin, and so the patients with type 1 can stay on insulin. But the cell therapy, of course, is much more, it's a much simpler approach. It would be probably a one-shot every year or two, and that would last you for a number of years, and then you perhaps to go back and have a top-up of a cell population. So I think it would be a much preferable way to go than have multiple insulin injections. There are other approaches, obviously, that are ongoing. There's something called an artificial pancreas, which is somewhat competitive to the cell therapy. It's two devices that are talking to each other, an insulin pump and a continuous glucose monitor. And if you can get these two devices to talk to each other appropriately, you can maintain your blood sugar. They are, of course, devices, and they are worn outside of the body, so it's a less convenient approach to treat the disease. In 5 years' time, an artificial pancreas will probably be available for patients. But I think still that's an interim step before we create the cell therapy that can actually cure the disease, as long as you have the immune modulating approach in addition to that.
At Celgene Cellular Therapeutics, our proprietary placenta-derived stem cells hold the potential to treat a range of serious diseases. Our unique processes for differentiating and producing treatments from this rich source of stem cells will enable us to deliver these therapies on a scale similar to today's biologic remedies. Proud to be at the forefront of this transformation of modern medicine, we are Celgene Cellular Therapeutics.